Hi guys, this is example 4 from our 8.4 lesson on trig substitution. And notice in this problem we have a definite integral, so we have limits of integration. Those limits of integration are in terms of x, and when we do our trig substitution we're going to get our answer in terms of theta, and then we can put it back into terms of x. So there's a couple different ways you can do this definite integral. One of them is to convert your final answer back into terms of x and use those limits of integration of square root of 3 and 2, or we can use some substitutions to convert those into terms of theta and evaluate it that way. So I'll show you what I mean. So first of all, this requires trig substitution. We have if you tried to do u substitution, if u was x squared minus 3, then du would be 2x, but our x is in the denominator. So that's why you can't use u substitution. So we're going to do trig substitution, and it's this form, u squared minus a squared, and we have, hold on a second, instead of u squared and a squared, we have x squared minus 3. And so my a squared, my a is going to be the square root of 3, because if you square the square root of 3, you get 3. So my u here is x, my a is the square root of 3, and so when we do the substitution, we end up with, we get x equals the square root of 3 secant theta, because it's a secant theta. So let's relate that to the right triangle, which I didn't do in the other examples in class just the other day. So this is, we can go back and we can look at that. If I divide this substitution right here, if I solve that for secant theta, I would get secant theta is x over the square root of 3. And the secant is the hypotenuse over the side adjacent. So if this is my angle theta, then my hypotenuse would be x. This side adjacent would be the square root of 3. And using the Pythagorean theorem, this side would be x squared minus the square root of 3 squared, which is minus 3. Okay, so this can help us figure out if we're doing the correct substitutions. That works, and so that's what we have here. So we are doing our correct substitutions. And if we continue with our substitutions, we end up with, we have that the square root of x squared minus 3 is equal to a tangent theta, and my a being the square root of 3 tangent theta. Now if I solve that for tangent, I end up with tangent theta is equal to square root of x squared minus 3 over the square root of 3. And checking that with our triangle, the tangent of theta is the opposite over adjacent, which does match. So that way you know you're doing the correct trig substitutions. So here we go. We still need to find dx. So let's do that. Here's my x. So dx is going to be, leave your constant, and then multiply, oops, square root of 3, not x, multiply by the derivative of secant, which is secant theta tangent theta d theta. So let's sub all that in. I'm going to remove this so I have more room to work here. So we have my limits of integration are going to change. I'm going to leave those off for right now, and I'll show you how to deal with that in a bit. But the square root of x squared minus 3 can be replaced with the square root of 3 tangent of theta. My x is the square root of 3, going to this right here, square root of 3 secant theta, and then dx is all of this. It's the square root of 3 secant theta tangent theta d theta. So you guys stop, stop the video and simplify all that to make sure you're doing it correctly. Check back in just a second. Okay, when you plug everything in, substitute everything in, and simplify it, you should get the square root of 3 times the integral of tangent squared theta d theta. Now we don't have a way to find the antiderivative of tangent squared theta directly, but we can use a Pythagorean identity, which would be the tangent squared theta is equal to secant squared theta minus 1. And then we can just integrate both of those pieces. So you end up with the square root of 3 times, in parentheses, because you have to multiply the square root of 3 through both of these. The antiderivative of secant squared is tangent. Tangent theta minus the antiderivative of 1, which would just be theta. So now I'm going to convert this back into terms of x, but I also want you to see how we can convert our limits of integration into theta. So let's do that first. Let's look at how we convert. So our limits of integration were the lower limit was the square root of 3, the upper limit was 2. So we are going to look at how to convert those into terms of theta. We know that when x equals, hold on one second. Okay, so when we have that x is equal to the square root of 3, so we're going to convert this guy right here. We have this, we know that x equals the square root of 3 secant theta in terms of theta. So that means that when x equals the square root of 3, the secant of theta must equal 1, because the square root of 3 times 1 would equal the square root of 3. And so now what you're doing here is we got to use an arc secant. We got to figure out what angle gives us a secant of 1. And so remember that secant is the reciprocal of cosine, so we're more accustomed to working with cosine. So that's equal to 1 over cosine. When does the cosine equal 1? And that is when the angle theta is equal to 0. So theta equals 0. So our limits of integration, our lower limit, if we leave it in terms of theta instead of converting back to x, would be 0. And then when x is 2, then we know that 2 is equal to the square root of 3 secant theta, because we know that's what x is equal to. And if we solve that by dividing, let me move this up a little bit. When we divide by the square root of 3, secant theta equals 2 over the square root of 3, or flipping both sides, we're trying to figure out when cosine of theta is equal to square root of 3 over 2. And hopefully you remember that that is at an angle of pi over 6. So if you convert these to terms of theta, you would integrate, you could just find your definite integral right here. It would be the square root of 3 times tangent of pi over 6 minus pi over 6 minus, and we're going to plug 0 in there, tangent of 0, which is 0, minus 0. So this whole piece will be 0 over here. And so then tangent of pi over 6, remember what that is. So if this is pi over 6, this is pi over 3, so this is a 30, 60, 90. We have a ratio of 1, 2, and then this is square root of 3. Tangent is 1 over the square root of 3. And I'm going to leave it like that instead of, because when I distribute the square root of 3, I'm going to get a 1. And then minus pi over 6 here. So distributing the square root of 3, we get 1 minus the square root of 3 pi over 6. And we can put that in a calculator to figure out what that answer is. So that's one method of doing it. Or we could have taken this answer here, the square root of 3. I'm going to do this in a different color. So this was our integral. Come on, computer. Square root of 3 tangent theta minus theta, and we can convert that into terms of x. All right, so we're converting square root of 3 tangent theta minus theta back into terms of x, and then we can use our original limits of integration. The lower limit was square root of 3 and the upper limit was 2. So let's do this. We have the square root of 3. I can distribute the square root of 3. So I end up with the square root of 3 tangent theta minus the square root of 3 theta. Now, using some substitutions here, the square root of 3 tangent theta we have directly in terms of x. It's x squared, the square root of x squared minus 3. So this becomes the square root of x squared minus 3, and then we have minus the square root of 3 times theta. Now we have to figure out what theta is, and if we use this substitution right here, this x equals the square root of 3 secant theta. We know that x equals the square root of 3 secant theta. We can solve this little piece for theta. First thing, divide by the square root of 3. And then we have x over the square root of 3 equals secant theta. To solve that for theta, we have to take the arc secant of both sides. So arc secant, well, here, let me just scroll down a little bit more here. We have the arc secant of this side. It's just arc secant of x over square root of 3, and the arc secant of the secant, they would cancel each other out, so we have our theta. So we're going to put that in place of this theta right here. So we have square root of 3 times arc secant of x over the square root of 3. And our limits of integration are square root of 3 and 2. So we're keeping those original limits of integration. We'll see that we get the same answer. So this was the answer we got when we converted our limits into terms of theta, and this is the other method that we can use. So let's do this. So we're going to plug in 2 in here and here. So we get the square root of 2 squared minus 3, which is the square root of 1, which is going to be 1, minus the square root of 3 arc secant of 2 over the square root of 3. And we just figured that out previously. That's pi over 6. So this becomes this, but then we have to subtract putting in square root of 3. Running out of room here. Let me do this. So now I'm going to put in the square root of 3 in for x here and here, and so I'm going to have the square root of the square root of 3 squared, which is just 3, minus 3, which is going to be 0, minus the square root of 3 arc secant of 0 over square root of 3, which is still just 0. And we just did that as well. The arc secant of 0 is 0. So all of this is 0. And so if we calculate, we get the square root of 1, which is 1, minus the square root of 3, and arc secant of 2 over the square root of 3 is pi over 6. And so that would be our final answer, doing it that way, which matches doing it the other way. You choose which way you want to do it. All right, that's it for example 4.